Hello again. How you doing? It is Monday. I'm recording this on Monday, but this is going to be for Tuesday, March 31st. And let me start off with a couple quick things, and then I will get into our little topic for today. First of all, I think we're all learning through this process about things that work and don't work. I'm probably a teacher who has been more on the side of not using as much technology as other teachers have. I've probably not used Google Classroom as much. So I am learning as well, and I apologize for any bumps in the road here. I will say this, I'm probably gonna start using Stream, my classroom Stream less and less, unless I have an announcement to make or something like that. And I will start posting things more as assignments. In fact, tonight, you'll have your first Google, it's actually going to be a Google form assignment that you will have to submit, and that'll be, I'll explain more here later, but that's going to be your assignment tonight, and that'll be found again under Google Classroom. It'll be an assignment there. So anyway, what I want to get to first is I want to do one problem from that worksheet you had yesterday. If you aren't sure what I'm talking about, it's this one. I actually commented on Google it's actually today, but it would be for you watching this yesterday on a question that I'm going to address more so today, but I think that hopefully helped you, and I'm going to hopefully clarify more. But I want to do one more problem from that in case you had trouble, and I'm going to pick number 10, okay? So you had to, in number 10 on that worksheet, you had to solve for angle A, okay? This is huge in a lot of these problems. So if the light bulb has not gone on for you yet, now hopefully when you look out for this, it will, and it's pretty easy. Here it is. If you have a diameter, which runs right through the center, you know right now that that cuts the circle in half. So from A through C all the way to B, this top half, that's 180 degrees automatically. So we know right now if that's 100, that this right here has to be 80. And if that's 80, what do we know about inscribed angles? They are half of the arc that they intercept. So of course the answer to that is 40, okay? Maybe that was easy, but if you had trouble with that one, I just wanted to point that out. Let me do two others though that are maybe newer ideas. I am working on getting a better board, by the way, than just using my daughter's 3-year-old board here. Hopefully I will have that up and running within a week or so. It'll be a lot bigger. I can put a lot more stuff on it. But let me do another one. And this question is not on that worksheet, although there were some like it on there. Instead, this is going to be, there were some like that on there, but you're going to have more questions like this tonight on the Google form you're going to submit. And it's a very important property, okay? So here it is. And actually, this is the one that I commented. I think it was you, Mr. Russo, who actually asked about this. It was a very good question. How do you do a problem like this when you have, let me see if I can draw it here. When you have a quadrilateral inside, let me go ahead and label a few things. I'm going to call this 125. I'm going to call this 88. I'm going to call this Y, and I'm going to call this one X. Hopefully you can read my handwriting. Never been the best. Okay, put my degree symbol there. How do you solve a problem where you have something like this, where you have a quadrilateral inscribed inside your shape, okay? Now, if we were in a normal class, I would go into a lot more detail and I'd probably give you a lot more of the why behind this, but I'll just make it nice and simple. We're trying to make things as basic as possible, so here it is. When you have a quadrilateral inside of a circle, has to be four-sided, by the way, the opposite angles are supplementary, meaning they add up to 180, no matter what. The opposite angles are supplementary. So right now, if you have to solve for X, well, we have a quadrilateral that's inscribed. Basically, 180 minus 125 would give you X, all right? And if I can do some quick math, sounds like that's 55, okay? So X equals 180 minus 125, and it looks like X is going to be 55 degrees. Okay? Same thing with Y. These opposite angles have to add up to 180. So 180 subtract 88 degrees. And it looks like we end up with, oh my goodness, 92. Did I do that right? 92 degrees. Okay, so if you really think about it, maybe you could make more sense of why this is. I'll just give you a really quick explanation. If I connect, let's just pick from here all the way around to there, that would be the arc for this angle here. And if I connect the other way, from here all the way around to there, the other arc, that would be the arc that goes with this angle. Now think about it. Both arcs put together are how much? 360, because it's the whole circle. So what do we know about inscribed angles? They're always half. So if the arcs together are 360, what are the angles going to be together? 180. That's the logic behind it. Opposite angles are 180. Okay, now I have one more property, and this one's different. Again, this will help you with what you're doing for your assignment tonight. Okay, so here it is. Has nothing to do with angles. Okay, so this one's different. It has everything to do with chord length. So let me go ahead and draw this in. Of course, we call a segment that cuts across a circle, we call that a chord. The longest chord in any circle, of course, is called its diameter. Okay. Let me go ahead and label some spots here. That's 4, that's 5, that's A, and that is 10. So another pretty easy one, and again, if we were in class, I would probably go into more detail on the why and give more of an explanation, but I'll give you the quick version, and here it is. When you have a circle that has chords that crisscross each other, doesn't matter how. This does not have to be the center, by the way. It's not. I tried to draw it so it was not. Here's the property. If you multiply both pieces of a chord, so this chord running like this, 5 times A, that product has to be the same as the other chord multiplied together, or those pieces multiplied together. So 5 times A has to be the same as 4 times 10. It honestly feels like you're cross multiplying because that's kind of what it is in a way. All right, so 5 times A is the same as 4 times 10, and obviously 5A is 40, and there it is, A is 8. Now, I don't think there are any like that on yesterday's worksheet, but you will certainly have some questions like that tonight. So again, the two main concepts we hit today: opposite angles in an inscribed quadrilateral always add up to 180. And when you have chords that crisscross, you multiply both pieces of the chord and set the two equal to each other. 4 times 10 equals 5 times A. All right. Hopefully that answered your questions, and hopefully that makes sense. You're welcome to email me anytime. Beginning next week, I will have what we call office hours from 11 to 1 every day, where I will be available by my computer. If you have questions, I'm kind of available this week as well, even though it's not official yet, but I just can't guarantee I'm always around my computer. But again, I'll try to get back to you when I can if you have questions. All right, hopefully that made sense. And your assignment is to do the attached Google Forms that you will find here. I like to use Google Forms for my assignments. We will, believe it or not, have our first assessment. It's just going to be like an Edulastic style quiz, but we will have one probably next week sometime. I'm thinking Thursday of next week. So I'll get back to you more on that when we get closer, but in the meantime, do the assignment I post for today, and I'll talk to you guys later. Thanks.